Welcome to the video on parabolas and transformations. Now, I will do basically a simple example, and then I'm going to show you a one that is more challenging that you could possibly see in more like a test or exam situation. Right, so the basis of this is you need to understand that transformation means changes. I mean, in English it means changes, so it's not different in maths. We are going to do 3 types of transformations, and these are the only transformations that you will do. It is shift up and down, okay? What do I mean by that? We are shifting the actual graph up or down. Now, when we shift up or down, we are moving up and down the y-axis. Remember that this is the y and this is the x. Okay, so we're going to look at that. And then we're going to shift left and right. And then also we're going to look at how a reflection works as well. These are the 3 types. So first we're going to start with what I call the mother graph of a parabola. And well, this is just this function. It's a standard parabola function. Okay. Now, if we shift, let's look at shifting this thing up and down. Okay. Whenever we shift up and down, let's say I'm going to shift this graph up by 2 units. Okay. If I do that, what is my new equation? All right. And how does this affect the equation? So obviously, if we look on the graph, if we shift this up by 2 units, so let's say that is now at 2. The turning point obviously is now going to be at 2. So our graph will look like something like that. Obviously, we'll have the same width, but I'm just giving you an example. So it's been shifted up by 2 units. Okay, and it only moves along the y-axis in this case. So how do we represent that in terms of the equation? Now, if we already know that our equation is y equals x squared, the only thing we need to do is add 2 to this. Okay, so basically whenever we have a constant added, in this case, in this type of formula, we know that it's a shift up or down. Even if it's in a different type of formula, that if you've watched the other videos, you will know that there's other types of formulas for parabolas. Even if it was, let's say, y equals x squared plus x minus 1, and we want to shift this function here up by 2, we would still just add 2. We would just add a constant 2 to the end, okay, to get the new function. So that is how we would change the equation, and in terms of the graph, we would just shift it up by 2. Okay, so that is shifting up. Shifting down is no different. Instead of being a plus, it would now be a minus 2. So if I had to shift this down to negative 2, okay, we would do the same thing. Obviously, it needs to be the same width, but my drawing isn't as accurate. So it's shifted down by 2. That means here, instead of putting a plus, you would put a minus now. Where you see I have added 2, I would now subtract 2. So that would just become a minus 2. Okay. Now, if we have a shift to the left and right, let's look at that. Okay. So let's look at a shift left and right. If we're going to do the same thing with this drawing and we want to shift it to the left, I'm just going to choose another color so you can see it more clearer. Let's choose blue. Okay, so if I'm going to shift the normal mother graph, so this one here, this one we started with, this y equals x squared, if I'm going to shift that by maybe 2 units to the left, let's say 2 units to the left, let's do that. What is going to happen? So now if we are shifting to the left, obviously we're going into the negative x-axis. So that's going to be, I don't know, this is not an accurate drawing, so I'm just randomly going to choose 2 over here. And this now is going to be shifted at this stage. Okay, we don't know where it's hitting the y-axis at this point. Okay. Yeah. So let us look at how this will change the equation. Okay, so we've obviously just shifted the whole graph to the 2 units to the left, but most of the time it's the equation that you guys struggle with. So let's look at that. So the original equation was y equals x squared. Now, if we are shifting this to the left by 2 units, what we have to do actually is where you see the x, we actually have to add 2, okay, and square it. So inside the x, basically, in this expression, we actually are going to change it and add 2 to x. Okay, so we're changing the x values now, which makes sense because that's what we're doing. We changed, do you see how it's shifted on the x? So we need to change the x. So that becomes plus 2. And why is it plus 2, not minus 2? This has to do with the fact that if you look at the root shift, okay, so if we want to shift it to the left, if we are looking at this thing here and we had to solve it, okay, remember how in quadratic equations where you have the bracket equals 0, so let's say it was 2 plus 2 equals 0, x will be equal minus 2. So if you set that to if you solve that, you would get minus 2 out there. So basically, well, it's just a standard rule that in the bracket, when you're shifting left or right, you have to choose the opposite sign. Okay, so just be careful of that one. So it's always going to be the opposite sign. Okay, so that will be your equation for left and right shift. So it goes inside the x. Okay, so let's just write that. It was x squared plus 2 squared. Now, if we're shifting to the right by 2 units, it would just be minus 2 in here. So you just change the sign. Okay, so careful with that one. Now, when we are doing the reflections are, I think, probably the most tricky ones. Now, I'm going to actually draw a new graph so we can see it a little bit clearer. Let's do that. Okay. Right. So if we had, let's say, a graph like this, okay, and this was the function, let's pretend it was this function, maybe minus 3, okay, and we want to reflect this thing. We want to reflect it about the x-axis, and we want to reflect it about the y. Okay. When we're doing this, these two things are very important. You need to be very clear on what they want you to reflect it about, because that is obviously going to change the way you do this. If we are reflecting about the x, okay, so remember that this is your x-axis, that's your y. So your x is over here, so let's just get some color going. That is your x-axis, so we're reflecting about that line. And that means that if I do a mirror image, on the other side, it's going to be at 3, and it is going to have the same x-intercepts. That won't change. And it's exactly a reflection. So what changes here is the y value. The y-intercept changes, okay? And obviously what else changes is now, instead of being a happy face, it's a sad face. Okay, so let's see how it affects that equation. So when you have got a reflection about the x-axis, you're always going to put a negative in front of your function. Now, I'm talking about the entire function. So you take the whole expression. So now you put a negative, so it becomes y equals a negative in front of everything. So keep it in a bracket so that it affects everything. And it becomes minus x squared plus 3. Okay, and that would be your new equation. So basically, when you have a reflection about the x, you need to make sure that it affects your entire expression. Okay, let's look at when it is reflected about the y-axis. The y-axis is slightly different. So let's do another diagram. The y-axis, let's do the same function, so we keep it the same. Oops, that one wasn't very straight. Okay, so this now is going to be the same function, so let's keep it as minus 3 there. Okay, now instead of reflecting about the x, we're going to reflect about the y. So let's just highlight that so we can see it. So we're reflecting about that one, and we are going to change the function. So that was y equals x squared plus 3. No, it was minus 3, sorry, because it's shifted down. Minus 3. Okay, now can you see what's interesting about a parabola is that when we look at this y and we want to have a mirror image on the other side of the y-axis, do you see we already have a mirror image actually? So the interesting thing about parabolas is when you reflect it about the y, it's actually going to become the same parabola. It does not change, because when we're doing about the y-axis, we actually insert the negative inside the x. Okay, so it actually goes like this: minus x squared minus 3, which just becomes, that becomes x squared minus 3, which you can see is the same function. Now, this is not always the case. Sometimes we do have parabolas that are not exactly symmetric about the y-axis. This is the case because it's a symmetric one. It's symmetric about the y-axis. You can see that. So let's do a case where it's not, so that you can see how that is slightly different. Okay, so when it is not symmetric, that means that maybe we're going to have something like, let's do going through the origin, and maybe we have something like that. Excuse my drawing skills. Minus 4 maybe. Okay, let's just pretend that's 4. Now, if we wanted to reflect this about the y-axis, now you can see that the y-axis is no longer a mirror image, because if you draw that line, you can see it's not the same on both sides. Like it was in this question, you can see it's exactly the same on the left and right side. But this one is not, which means that it is going to be different. So if we draw it, we can draw a nice reflection. It's going to have the same turning point in the y value. So the y turning point value won't change. Now we're going to have minus 4 there, and I'm going to show you how we get that. But do you see how now it's exactly a nice mirror image over that y-axis? It's exactly, if you look left-hand side, right-hand side, it's identical. So, okay, so let's see how this affects the equation. Right, first of all, let's actually just get this equation. How would we get this equation of the first one? It was, okay, let's go back to our skills. So we have got not our turning point, but we have got a 0, 0 point, 2 intercept points, and the y value of the turning point. So what I'm going to do is just pretend that I do know the turning point here. Well, it should be 2. Okay, so that should be a value of 2, because this obviously will be, so we will know the turning point. So let's just use the turning point formula. So it'll be a x now turning point is plus, so it'll be minus 2 squared minus 4. Okay, to get A, you're just going to have to sub in another value. So I'm going to sub in the origin. Okay, to get A, if you don't know how to do this, you go look at the other videos that I made. Okay, we're going to solve for A. That's going to be 4A minus 4. So A is equal to 1. Okay, so now we have our equation and we're going to reflect it. Okay, and how does this change? Okay, remember I said to you y, with the y, it changes the x. Okay, so it changes the x value. So anything within the x here will change. So it needs to go y equals minus x, and this becomes a plus 2 squared minus 4. So anything in here changes its sign. Okay, right. So that we are on now the other side of the other side of y, basically. Our x values have changed. Okay, so I hope that makes sense to you. Yes, and then we will have a nice, you can see here will be your minus 2. Yeah, okay. So any questions there, you can always let me know.